What's up everybody, and welcome to a new video. And in this video we're going to go over my notes for sets in Python. So here the first note is about the definition. Namely, I define a set to be a collection of unique values, i.e. there are no duplicates. So to show that, let me here create a set by using those braces here. So just like dictionaries, sets use these braces here. However, in contrast to dictionaries, where we insert here key value pairs, in the set we only insert values separated by commas. So for example, if I insert here a 1 and another 1 and then 2, 2 and then 3, 3, and now if I run this cell, then you can see that the set here that is created from that actually only contains the numbers 1, 2 and 3. So there are no duplicates here. And here I also have a side note, namely this also applies when the items or elements are of a different type, but nonetheless represent the same value. So to show that, I've prepared here this set. So here I have inserted a 1 as an integer, a 1 as a float, a 1 as a complex number, and then here this Boolean value true, which also interpreted as a 1. And now if I execute the cell, then you can see that this final set here actually only contains a 1. So as you can see, sets are really a connection of unique values where there are no duplicates. Then the next note states that sets can only contain objects that are immutable. And we will talk about mutability when we talk about here these miscellaneous topics. And then here we have mutability. So if you don't know what that is, then I will put a link to that video into the video description. But now I just want to show what that means for sets. So therefore I've prepared here this code. So let me paste this here. And here what I'm doing is I'm importing this math module. Then here I'm defining a function. Here I'm defining a class. And then here I've created a set with different Python objects. So here at first we have an integer, then here a float, complex number, a string, a Boolean value, the non-value, a tuple, then this module here, then the function, and then here this class. And now if I run this cell, then you can see that we don't get an error and that all of these objects here are listed in our set. So those are all immutable objects. And now, however, if I try to create a set that contains, for example, a list with 1 and 2, then if I try to run this, then you can see that we get here a type error because we have an unhashable type, which is this list. This is also true for sets. So for example, if I make this here a set, then if I run this, then we get here again type error. This time the unhashable type is a set. And this is also true for dictionaries. So if I make this here a dictionary, then the unhashable type now is a dictionary. And here I also have a side note. Namely, this states that tuples can't be used as items or elements if they contain mutable types. So for example, here we have this tuple in the set. And if I now insert here a list, for example, and then try to run this cell, then again we get here this type error because now we have this unhashable type, which is a list. So this is what I mean by this note, that sets can only contain objects that are immutable. So now let's go over these side notes here. And the first one states that sets can be empty. However, if you want to create a set, then you can't use here just those braces, because this is here now actually not a set, and we can verify that by using this built-in function type. So if we check the type of A, then we can see that this is actually a dictionary. So this is an empty dictionary. So if you want to create an empty set, then you have to use the built-in function set. So now again here, if I use this type function and check the type of A, now we can see that now it's actually a set. So this is how you can create an empty set. And then the next side note is or states that in contrast to lists or tuples, sets are unordered. So to show what I mean by that, I prepared here these two lists. So here we have list 1 and list 2. List 1 contains the values 1 and 2, and list 2 contains the values 2 and 1. So it's the other way around. So now if we say here list 1, is that equal to list 2? Then we get a false because they are not the same. However, if we do something similar with sets, so here I have a set that also contains the value, or set 1 contains also 1 and 2, and then set 2, 2 and 1. So now if I say here set1 is that equal to set2, then we actually now this time get a true, because those are still considered to be the same, because they contain the same values, and the order of those values, however, doesn't matter. Okay, so those are those side notes. And with that, now we've covered all my notes with respect to defining what a set is and how sets are denoted. So then the next note states that sets are the data structure with probably the most specific use cases. So for example, the main use case for sets is to compare two or more collections with regards to their items or elements, i.e. to use them for set theory. And we talk about set theory in more detail when we talk about here the methods. So let's get here now to this side use case, which is to find unique values in a collection other than a set. So to show that, I've prepared here these two variables. So here we have a list and a string, and now let's simply transform them into a set by using this built-in set function. So if we say here set for this list, then we get here a set that only contains 1, 2, and 3, so only the unique values of this list. And the same thing also applies here to the string. So if we transform that into a set, then we get here the set that contains E, H, L, and O, which are the unique values of this string here. So those are the most typical use cases for using sets. So now let's go over the available methods for sets. And here I've grouped them into these categories. So the first one is about adding or removing elements from a set. And here the first method is simply called add. And with that you can add elements to a set. So to show that, I've prepared here this set, which contains the values 1, 2, and 3. And now let's say that we want to add a 4 to this set. So therefore we then simply say set_1 and then add. And then here we want to add a 4. And then if I print out this set, then you can see that it now contains here this 4. So this is how this add method works. But now let's also see what happens when we try to add an element that already exists in our set. So for example, now there's this 4. So therefore now let's here simply rerun the cell here again. And now if I print out the set again, then you can see that it hasn't changed and it still contains here only 1, 2, 3, and 4. Then the next methods are called remove and discard. And with those you can remove elements from your set. So for example, if we create here the set again, and then let's say that we want to remove here this 1. So therefore then we would say here set1 dot remove, and then we want to remove the 1. And now if I run this and then print out the set, then you can see that the 1 was removed and only the 2 and the 3 are left here. So now let's also see what happens if we try to remove something that is not in our current set here. So let's here then again say set1 dot remove, and let's again remove the 1, or try to remove the 1. And then here, as you can see, we will get then actually a key error because there is no 1 in our set. And this is also the difference to this discard method. Namely, this doesn't throw an error. So for example, if I replace here the remove function with the discard function or method, and then run these cells here again, then you can see here we don't get an error. And it looks like that this discard method is not doing anything. However, it's actually returning a none value. And I can show that by here simply printing out the value. And then here you can see that it actually returns a none. And then the next method is called pop. And with that you can simply pop elements from your set. So to show how that works, I've prepared here this set. So this simply contains the strings hello and world. And now let's use this pop method. So let's say set1 and then pop. And here you can see it returns the hello. And now if we look at our set, then we can see that hello was removed from our set, and now it only contains world. So now let's run this again. So let's again say set1 pop. So this time it pops world, and then if we look at a set, then we can see that it is empty. So now let's also see then what happens when we try to pop from an empty set. So again, set1 and then pop. And here you can see that we get a key error because we try to pop from an empty set. So this is how pop generally works. And here I also have a side note, namely that states that the element that gets popped is arbitrary but not random. And to show what I mean by that, I have prepared here this code snippet. So here I'm running a for loop with 10 iterations, and then in each iteration I create here the set that contains the strings hello world and universe, and then I use here the pop method 3 times and store the respective return values into these variables here. And then at the end here I simply print out those variables. So now if I run this, then you can see that we get this result here, where in each iteration we have then the order of those strings here to be universe, hello and world. So as you can see, this order is not random because we always get in each iteration the same order. However, the order is however arbitrary, and to show that, let me here simply restart the notebook, and then let's copy and paste the cell here, and now let's run it again. And now, as you can see, we get a different order. So this time we have world, hello, and universe. But again, in each iteration, this order is the same. So it's not random. However, it is arbitrary. So this is how pub works. And then lastly, here we have clear. And with that, you can simply clear a set, i.e. remove all its elements. So for example, to show that, let's use again here this set with 1, 2, and 3. And now if I simply say set1 dot clear and then print out this set, then you can see that we now here have this empty set. So those are all the available methods for adding or removing elements from a set. Then the next category is called mutability, and here we only have this copy method. So again, if you don't know what mutability is, then you can check out the link to a respective video in the video description. But now I just want to show how this copy method works in the context of you working with sets. So therefore I've prepared here this code example. So here I'm creating those 3 variables a, b, c. A is a set that contains 1, 2, and 3. B is then set equal to a, and c is set equal to the copy of a. So now to see what this copy method here does, let's print out the IDs of all those variables here. So we're going to say print ID of a, and then we're going to do the same thing for b and for c. And then here you can see that a and b have actually the same ID, whereas c has a different ID. So what's going on here is that when we say a is equal to the set, what happens is that the set here is created and stored then in a specific location in memory, and then a simply points at that location in memory. And then here, when we say b equals a, then b is simply pointing at whatever a is pointing at. And since a is, so it's also pointing at this set here, and therefore then we have here those same IDs. And then here, when we say c is equal to the copy of a, what happens here is that this copy here method creates a copy of the set, and that copy is then stored in a different location in memory. So that's why then we get here a different ID. So this is how this copy method works. So then the next category is called set theory. And here the first 2 methods that we're going to cover are intersection and intersection update. So let's first look at what an intersection actually looks like. So therefore, let's open here this image. So here we have set 1 and set 2, which are these circuits, and the intersection of those 2 sets is this area here, this blue area, where those 2 circuits here intersect. So now let's see what that looks like here in Python. So if therefore I've prepared here these 2 sets. Set 1 contains 1, 2, and 3, and set 2 contains 2, 3, and 4. So now let's see what the intersection of those 2 sets is. So we're going to say set 1 and then intersection and then set 2. And now if I run this, then you can see that we get a set with a 2 and 3 because that's the intersection here of those 2 sets. And now let's also see what happens if we do it the other way around. So if we say here set 2 and then intersection with set 1, and in this case then we get the same result. So this is how the intersection method works. So now let's also see how this intersection update method works. Namely, this simply updates the respective set in place. So for example, here if I don't use here this intersection method, but instead the intersection update method, then you can see that this doesn't return anything. However, if I now look here at set 1, then you can see that this is now set to 2 and 3 because that's the intersection of those 2 sets here. So this is how intersection and and the intersection update method work. Then the next methods are called union and update. So let's again first look at what union looks like by looking at this image here. So here we have these two circuits again, and then the union is simply the whole area here for these two circuits. So again, let's see what it looks like here in Python. So therefore, let's use here these two sets again. And then let's say set1 dot union with set2. And now if I run this, then we get here the set which contains 1, 2, 3, and 4. So now let's also do it again the other way around. So set2 with the union of set1. And here again, we get the same result. So this is how union works. Then let's also check out how update works. And again, this simply then updates the respective set in place. So for example, here if I then say set1 update set2, then it doesn't return anything again. And so if we look at our set1 now, then we can see that it is set to contain the values 1, 2, 3, and 4. So this is how union and update work. Then the next methods are called difference and difference update. So let's again look at what the difference looks like. So therefore, let's open this image here. So here we have two different versions. So if you want to see the difference of set1 to set2, then it is this blue area. If you want to see the difference from set2 to set1, then we have here this blue area. So again, let's see what it looks like here in Python. So therefore, let's create those sets here again. And then here, if we say set difference to set2, then we get here a 1, because that's the difference here to this set2. And if we do it the other way around, if we say set2 dot difference to set1, then we get here a 4, because that's the difference to set1. So this is how difference works. And now let's see again how this difference updates method works. And again, this simply updates the respective set in place. So here then, if we use difference update, then again, it doesn't return anything. However, if you look at set1, then we can see that it now only contains here this 1. So this is how difference and difference update work. And then lastly, we have symmetric difference and symmetric difference update. So again, let's look at what the symmetric difference looks like. So therefore, let's open this image here. And here, as you can see, the symmetric difference of set1 and set2 is in this case here are these outer areas. So symmetric difference is basically the opposite of the intersection. Okay, so now let's also see what that looks like here in Python. So if we say here set1 and then symmetric difference to set2, then we get here the 1 and the 4, because that's the symmetric difference of those two sets. And again, let's see what happens if we do it the other way around. So here, symmetric difference of set1 to set2 to set1, then we also get here a 1 and a 4. So that's how symmetric difference works. And then let's also see again what this symmetric difference update does. Again, it simply updates the respective set in place. So for example, if I then say here update and then run this, again, it doesn't return anything. However, if you look at our set1, then we can see that it is updated to only now contain 1 and 4. So those are all the available methods with respect to set theory. Then the last category is called checks. And here the first two methods are called issubset and issuperset. So let's again first look here at this image to see how they are defined. Namely, here we have these two circuits, a smaller one and a bigger one. And if the smaller one is completely within the bigger one, then you speak of a subset and a superset. However, if the circle or the smaller circle is not completely within the bigger circle, then you don't speak of subsets and supersets. So now let's see what it looks like here for Python. So therefore, I've prepared here another set. So this is set 3, which only contains 1 and 2. And now let's check if set 3 is a subset of set 1. So we're going to say set 3 is subset of set 1. And now if I run this, then we get here true, because both of these values are in set 1. And let's now also check if set 3 is a subset of set 2. So we're going to say set3 is subset of set2. And then here you can see we get a false because set2 doesn't contain here this 1. And now let's also do it the other way around. So let's check if set1 is a superset of set3. So let's say your set1 is superset of set3. Then again, here we get the true. And let's now also do the same thing for set2. So we're going to say set2 is superset of set3. And here again, we get a false. Okay, so this is then how issubset and issuperset work. And then the last method is called isdisjoint. And here again, let's look first at this image here to see what it looks like. Namely, when those two sets don't overlap at all, then they are called disjoint. So now let's see what it looks like here in Python. So therefore, let's replace here those values with 4 and 5. And now let's check if set3 and set1 are disjoint. So we're going to say set3 is disjoint with set1. And here we get a true because set1 doesn't include any of those values here from set3. However, if we then say set3 is this disjoint with set2, then here we get a false because set2 also contains here this 4. And we can also do it the other way around. So for example, if I say here set1 is this disjoint with set3, then we also get a true. Or if I say set2 is this disjoint with set3, then we also again get here a false. So this is how this joint works. And with that, now we've covered all the available methods for sets. And with that, now we've covered all my notes that I want to cover with respect to sets. So we've reached the end of this video. And then in the next video, we're going to go over my notes for these miscellaneous topics with respect to data structures. So thanks for watching, and hopefully I will see you in the next video.